So let's start with who am I? I work mostly on secure infrastructures, build systems, release engineering, and CI/CD automation. So most of my life revolves around making sure software behaves exactly as it is supposed to be. Now, some of you already know that I am deeply attached to the FreeBSD ecosystem, and yes, a lot of my experience comes from that world, but just to be clear, today I'm speaking with my personal hat on, not on behalf of any organization. This is me sharing some scars, lessons, stories learned from the trenches, and things that happen when trust and automation meet the reality. And fair warning, I do break things in the name of security and innovation, not for chaos, but to surface the assumption that systems make and to rebuild them with proofs instead of hopes. So let's start with some history. Today's session is actually not about one single operating system or one single language, but it's actually about a mindset. The belief that we are actually in control of the application or the softwares we use, when in reality, the control is actually often an illusion. There was a time, a long time ago, when we built everything ourselves. Gentoo, Linux from scratch, FreeBSD's make worlds. Every binary on our system came from your own hands, my own hands. You earned it through hours of compiling. Uh, we didn't call it software supply chains at that time. Uh, we called it Friday night. That era actually has taught us some sort of ownership, but definitely it's taught us how to handle pain. In 1991, Linus Torvald released the Linux kernel, but a kernel isn't actually an operating system. You need userland, you need unit systems, you need package management. So came Slackware, Debian, Red Hat, Gentoo. Each added convenience and took away a bit of autonomy from us. The social contract actually changed. Instead of I built it myself, we said someone reputable built it for us. So let's meet Linux from scratch. In 1999, Linux from scratch was created, which was actually a guide building a full system based on the Linux kernel, including the userland tools, but manually. It was actually a school for system thinking. Kernel to userland mapping, init systems, linking, why package managers actually exist. LFS was never about a finished product. It was about learning how the pieces fit together, how a compiler bootstraps, how init actually starts a system, and why the package managers exist. It was a rite of passage, a very painful one, but enlightening. It was a foundation for real security intuition. I built LFS and got an existential crisis. Let me tell you a story. I once decided to build Linux from scratch. Day 0, excitement. Day 7, madness. Day 14, enlightenment. When the machine finally booted, a virtual machine, I felt triumphant. Then I stared at a blinking cursor and realized I had absolute control and nothing to install. That's when it actually hit me. I discovered control without reproducibility, without sustainability, isn't actually control at all. It's just another illusion wrapped in a tarball. So let's look at why enterprises actually stopped doing builds by themselves. Enterprise learned the lesson very quickly, building from sources that actually scale very well. So we invented package managers, release pipelines, vendor repos. We convinced ourselves that if it came signed, it must be safe. Security actually became an assumption baked into tooling while it was not a verified truth. Ask yourself some questions. Where did the last binary you actually used came from? Upstream? A random CI system? Is it really the same code you actually reviewed a week ago? SolarWinds, CC Cleaner, XZ Backdoor, all modern reminders that signed doesn't mean safe. We have built enormous systems of trust on documentation and hope. But does this sound like zero trust? Zero trust is actually built upon principles: never trust, always verify. We apply it to networks, to identities, but not to our own build systems. Pre-built binaries mean trusting strangers, compilers, more than your own. If you don't control your build, you don't control your security. Let's look at the cultural shift. We have automated ourselves out of awareness. Pipelines, software bill of materials, container registries replaced human oversight. Convenience actually became a deity for us. And security turned into a checklist rather than a discipline. But we actually need a far, far better way. So let's enter zero trust builds. Zero trust builds actually flips the assumption. Every artifact that we use must be reproducible and verifiable. We verify what we deploy, how it was built, and where every dependency comes from. This is the do-it-yourself spirit, but it is industrialized. Let's look at how an operating system build works today. So it looks like the source, then CI or continuous integration, packages, release images, and then it goes to users. But every step actually hides a potential attack surface. Like timestamps, scripts, dependency fetches. While our automation actually made it faster to build, but it also made it faster to compromise. Who signs the binaries? We sign releases. We feel very good about that. But a signature actually proves who built it, not what they built. If a compromised build system actually signs a malicious binary, someone just notarized that problem. So let's look at how we can actually implement zero trust in software builds. To fix this, we actually need 4 different things: source of truth, reproducible builds, isolated environments, cryptographic verification. But this isn't actually idealism, it's just doing trust in the right way. When I actually work with clients, we implement all 4 pillars, but with limited time, I will focus on the pillar everything else depends upon: source of truth. By source of truth, I actually mean a single signed, immutable manifest of every input to the build system, like repos, exact commits, toolchains, compilers, configs, all of it. If it enters into the build system, it's named, digested, and allowed only from an approved origin. If your build system cannot tell like what it used, it actually not your build system. It is someone else's build system. Does your eye actually read the difference between the first two links? The number one is FreeBSD, the second one is Free6SD. One character difference, a real example of a typo squat that could compromise an entire pipeline. Review fatigue is actually the new 0-day. Humans don't notice one character, computers don't care at all. A few years ago, I worked on a long, complex security hardening document, which is public right now. It went through 15 independent reviewers, some of the very best security professionals I know, people I deeply respect. Every paragraph was checked, cross-checked, commented, rewritten, and still a few subtle mistakes slipped through the final release version. It was not because anyone was careless, but because human cognition actually has some limits. After the 10th review, your brain will most likely reading what it expects to see, not what's actually there. That's what actually attackers exploit: fatigue, familiarity, and trust. We can automate checks, enforce diff, sign commits, but no amount of process replaces the limits of attention. And that's what actually makes this one character changes so dangerous. I once worked on a high-stake infrastructure audit for a financial trading firm. They had been quietly losing hundreds of thousands every month and couldn't find out why. Everything looked fine. Logs, codes, signatures, until we actually dug into their CI/CD pipeline. Buried in the checkout stage was a single deliberately mistyped repository URL at a cron job. One character off. That clone actually pulled a forked version of an internal engine. The internal engine that was actually used to decide how trades were executed against retail traders. For a couple of hours each day, that forked engine was silently enabled, and a small group of insiders traded against the house. 8 months, millions lost, all from a typo. No malwares, no 0 days, just trust and exhaustion. So attackers actually don't need to be smarter than us. They just need us to be tired. Anyone here who doesn't know this? No shame in it. I know you will definitely know the next iteration of it. This is the infamous 1990s fork bomb. 16 bytes that taught an entire generation what uncontrolled recursion feels like. It's funny until you realize it's actually a metaphor of our ecosystem today. Processes replicating endlessly, each consuming a little more trust until the system stops responding entirely. So let's meet the 21st century fork bomb. Look at these repos. Tens of thousands of forks, a modern fork bomb. Each fork copies the code, the dependencies, and the vulnerabilities, but rarely the understanding. We have industrialized replication. Knowledge didn't scale as fast as cloning did. Every Git clone is actually another act of faith. We replicate faster than we verify. And then we call that open source velocity. It's just an entropy with a good intention. It's not malice, trust me. So let's look at some of the hidden challenges. Reproducibility actually sounds very simple, but it's brutally hard. Changing a timestamp, a local UUID, a path, and you have broken determinism. Any open source developer, you can ask them. And if upstream actually cannot reproduce its own builds, enterprises cannot verify anything downstream. And at that point, audit actually becomes a theater because we are proving processes, we are not proving binaries. So what can an upstream developer can do actually? Reproducibility actually starts by some methods, like setting source data epochs, maybe fix seeds, avoid internet fetches during the build time, pin the dependencies, normalize locals, use diffoscope type application to verify that they are built byte by byte, same. These aren't actually build flags used by compilers, they are acts of empathy towards everyone who depends on your code. A quick intro into the reproducible builds project itself. This isn't actually a distro badge. It's a community effort to make builds verifiable. The idea is very much simple, that given the same source and declared environment, independent parties should produce identical binaries. And when that happens, we can detect tampering and supply chain drift with a byte level comparison. The project supplies the normalization guidance, the source data epoch convention, test tools like ReproTest, and a diff-like application like diffoscope, which compares different binaries byte by byte. It also coordinates patches, upstreams, and publishes living documentations and report for different operating systems. In zero trust terms, this is actually the mechanism that turns trust into a test, which you can actually pass or fail on purpose. So what should be the next step for enterprises who are actually based upon open source builds? Start small, pick one very critical package, rebuild it yourself, compare it with upstream binaries, track the differences, if there are even any differences. Reduce the reliance on external repos at any cost. Treat build integrity as a first-class security goal, not an academic exercise. Zero trust build will not happen overnight because they happen one package at a time. So here is my final thought. We have gone from I built it to someone built it for me to a robot built it for everyone. Each step actually removes some friction and understanding. At some point, convenience actually stops being an optimization and it starts becoming a vulnerability. Convenience isn't evil, but every layer of it distances us from its consequences. Passion writes the code, but money decides its future. Even in open source, sustainability has a cost. The question is, who is paying and who is verifying it? So I will leave you with 3 questions. What's stopping you from verifying your own artifacts? How much trust debt have you silently accrued? And where will you draw the line between convenience and control? Thank you.
Thank you, Moin. We have some time for any questions for Moin. So I don't see any questions. It's a bit lighter than before. The lights have gone up. Okay, so please join me thanking Moin for a fantastic presentation. Thank you so much, Moin.